Welcome to our webinar Wednesday on National STEM Day, and thank you all for being here. We're looking forward to sharing with you some ideas about how to do an egg drop challenge or any other engineering challenge you want to try to celebrate National STEM Day and also help you learn about and develop the practices of engineering. We're going to be focusing in particular today on testing and retesting and how this can help you develop strategy or life skills like perseverance and learning from failure. I'm Dr. Sandra Frericks. I'm a science education specialist here at the University of Nebraska, and I'm joined in our webinar today by Marcel Walton, who's our marketing and communications intern. Marcel will be following along in the chat box. Thank you for joining us. As we get started today, I want to share with you a graphic of the engineering design process so you can see how the different strategies or practices that engineers use come together in this process that is a problem-solving process that helps engineers reach good solutions, and it helps young people develop important skills that are going to be important to them in life. We're going to be focusing on how helping youth develop these practices as an engineer, such as testing and evaluating their prototype and improving their design, can also help them develop important skills that they're going to need throughout life. This particular graphic comes from teachengineering.org, which is a great resource for you. It has a digital library with hundreds of free engineering resources, all supported by the National Science Foundation. So I recommend that you try it out. As you leave the webinar, you will have strategies that you can use to help the staff in your after-school program develop the skills that they need to support engineering, and also strategies that youth can use to help them evaluate what is or isn't working as they go through the design process and redesign their solutions, and also persevere and learn new skills through engineering. The practices of engineering, or this idea of engineering practices, comes from the science framework for K-12 education, which was set forth as a new vision for science education in 2012, and has become the basis of the next generation science standards. The framework really shifts our thinking about what it is to teach science. It focuses on big ideas and developing practices rather than being able to recall specific information. In this new framework, understanding is viewed as what students know and are able to do. The framework identifies specific practices of an engineer, and you can find more information about these practices at the National Science Teachers Association website, nsta.org. But what I want to specifically point out is that these practices build upon one another. As students develop and use a model or a prototype that prepares them for the next step of planning and carrying out an investigation, which is a purposeful testing of their idea. It can be a real-world testing of a prototype or a virtual testing of a model or simulation on the computer. From that, they're going to generate data about what worked and didn't work in their testing. And so we want to help them have the skills that they need to make sense of the data that they've generated in the testing process, and then be able to use mathematical and computational thinking as a tool to make sense of that data. Now that sounds complicated, but it really can be as simple as totaling the numbers of successes and failures for their prototype. That's using mathematical thinking to total successes and failures. If you want to get into more complicated thinking, they can use some computational thinking to average the results and even to make that into a graph or something they can display. So those are the specific things we're talking about when we say we want youth to be able to use the practices of engineering. And the last one is also important too. After they've gone through this process of creating a solution to a problem, We want them to have the skills they need to communicate about their solution. They may be communicating in writing, verbally, through videos, or using images. All of those are important skills that scientists use to communicate about what they've done. I want to emphasize that these are the practices that young people are doing. It's not practices that we're doing for them. We really want to see the youth doing this themselves. The framework expects that even in the early grades, youth can and should be solving problems and using those skills. And that we know and we expect that their skills are going to get better, that they will develop over time. So the more they practice problem solving, the better the solutions they're going to generate are going to become. And what our role then is going to be to provide a safe and supportive environment where they can develop their skills and try them out. And this is really important as we think about after-school programs as a place for youth development. It's a place where we help children develop to their full potential. We're really not trying to create engineers in our after-school program, but rather we're trying to use engineering as a strategy to help young people develop life skills that they're going to use in all areas of their life. We want them to have the opportunity in after school to practice these skills, to make mistakes, to fail, and to learn from their failures. So we need to create an environment that focuses on learning, that is supportive, and helps youth develop to their full potential so that they are able to say, I can solve problems, and I can receive feedback on my ideas. I can change my ideas. These are all important skills that youth don't necessarily have as they come into our program. So we're going to give them opportunities to practice these skills and learn them through science and engineering, and then help them be able to apply these skills in other areas of life as well. In order to do this, we need to make sure the staff in our after-school program are well prepared to create these supportive environments. This is the Click to Science model of professional learning or of professional development, and it is intentionally designed to help staff develop the skills and competencies that they need to provide high-quality STEM learning experiences to young people. This model is based on best practices and research from our field and others. And if you want to see more about the research that has informed this model, check out the research and evaluation part of the Click to Science website. What we're going to focus on today is how you can use this model and resources from clicktosciencepd.org to create an experience for your staff that will develop their skills. Today in our webinar, we're going to focus on the specific parts of the model that are darkened here. We're going to start with a meeting resource and then continue on around the model. A lot of our trainers actually prefer to start with the web lesson, which is where we're going to end today. So I'm showing you a little bit different way to use the model, because what we want to emphasize is that the model provides you a research-based structure for your professional development, but it also gives you a lot of flexibility to make it work within your program. The important idea is that these are a series of experiences that are connected to one another and build on one another, and that you give your staff opportunities to practice these skills working directly with youth, because that's where the change really happens. All right, so we're going to see what you can do to help empower the staff in your program to help prepare them so they can help youth solve problems, persevere against hardship, and learn from their mistakes. We're going to start this out today with a video from the Click to Science website that highlights the egg drop activity. You may have done this challenge before, where you provide or design a container or a carrier for the egg to protect it against all the challenges of life. As we watch this video and you see how the staff are preparing youth for the egg drop experience, I want you to pay particular attention to the big life lessons that are covered in this activity. What are the skills that the life skills that youth are going to develop from the egg drop challenge? And then following the video, we're going to use Chalk Talk, which is a professional development strategy for you to share what you saw in that video and have a silent conversation with other peers about what they noticed in the video and how you can learn from one another. All right, let's start with the video first.
Five, four, three, two, one.
In this activity, youth design a package that will keep an egg from breaking using the steps of the engineering process.
In a group, you guys are going to be designing. You guys are going to be designing that packaging, and then we're going to be testing it.
Youth work in groups to collaborate and brainstorm a design that will help a farmer get his eggs to market safely without breaking.
And then we could use a cloth right there, so if it falls, it could land on the cloth and it won't really break.
Try to see if you guys have a plan B, just in case that one doesn't work. Because remember, there's 2 days of trials. So today we're going to be doing the tan bark one, and tomorrow's going to be a cement.
All right, I'm going to take care of the egg part, okay? But I
Okay, so now we're gonna go test, and when we come back, we're gonna show, right?
5, 4, 3, 2, 1.
Alright.
Oh, I can't.
Alright, but it survived, right?
Yeah.
You guys can see already?
Okay, so on the bottom we put some cotton balls. After that we wrapped the egg with bubble wrap, and then with the cloth, and then bubble wrap again.
You're right. So do you guys feel like this would hold up, or do you guys think that you guys are gonna have to modify it a bit in order to make it successful?
Yeah.
You guys think it'll hold up? Okay.
Today, you guys are going to get less bubble wrap and less tape. How are we going to use the kebab sticks?
We're going to stab it into the box.
4, 3, 2, 1.
It's fine.
Alright.
Good job, you guys. Good job. Good job.
All right, I'll give you just a moment to think about what it was that you noticed in that video. What are the big life lessons that youth are learning from this, and how are the staff supporting those lessons through what they do? Let me pull up the chalk or the whiteboard so that we can discuss that. All right, now you can take a turn to share your ideas and your observations. Just use the T control on the left-hand side to add your text to the whiteboard. That's a great set of ideas about what is happening here and what you noticed in the video. A lot of emphasis on solving problems. That seems to be the big life lesson that youth are learning from this experience. Go ahead and hide this, and we're going to watch another video so you have a chance to see what the next step is. Now, in the second video, I want you to pay attention specifically to perseverance. What are the staff doing to help support you in developing perseverance through this problem-solving challenge?
The engineering process during STEM explorations involves trial and error. Watch the adult encourage youth to investigate how they design their package, what did or didn't work with their design, and how they might adapt for retesting. Staff support youth's abilities and do not provide the answers for them, but instead encourage youth to work with their team and develop their own solutions for retesting their designs. Pay special attention to the interaction between frontline staff and the group whose egg did not survive the retesting process.
Your egg was successfully safe, right? But tomorrow we'll be dropping where? Cement. So what? Those are all good ideas that you guys are gonna have to think about, and then get ready for tomorrow. Okay? Good job.
We should take this off, and then we should close it, and then you know how I think one of you said that to put bubble wrap all around it.
And then we put the egg inside, and then we have to find something to close it. She's just like,
All right, so you guys,
I just want to ruin that.
just drop.
So let me pull up the whiteboard here and give you a chance to share some more ideas. So our question now is what are they doing to help support developing perseverance? How are they preparing them for the potential of failure? And you can just type in your ideas there in the chat box. Looks like we typed over each other a little bit, but we have some ideas about what they do to help prepare them emotionally in thinking ahead for the second day of their engineering challenge, where they think failure may be more likely to happen. And they're really helping them think through the thought process, asking what didn't work the first time they tested it, sharing some ideas about what they could change for the second day of testing. Part of what they've done in this activity is just set up this idea that there's 2 days of testing, and that helps prepare youth for the potential that things may not go quite the way that they want to, and that perseverance is part of what is required in this activity. So as you're going through this model with your staff, first you would have a staff meeting where you watch the video and then do the chalk talk together to give them a chance to reflect on what they see on the video. And then they could go out and actually lead the egg drop activity with the youth in your program, practicing some of the strategies that they just talked about. After they've had a chance to practice preparing youth for testing and retesting and have done an activity like this, we're going to follow this up with a coaching guide. And the coaching guide we're using in this session is called Retesting and Success. And I should point out that both this coaching guide and the Discussing Testing in the Design Process guide for the staff meeting are available for you to download from the Click to Science website or from the pod over to your right here in the webinar. So the follow-up after you've done the meeting with all your staff and given them a chance to practice is to meet with people individually and help them create their own SMART goals that will focus on what changes they want to make in their own program. The important thing to remember as you're setting goals with your staff is that it really needs to be their goal in order for it to be effective. And then your role is to help them take their idea about what change they want to see happen and turn that into a SMART goal. A SMART goal is specific so that you know exactly what it is that they're trying to accomplish and they know what it is they're trying to accomplish. It is measurable, and you will know that the goal has been accomplished because you have a clear measure for success. It is an achievable goal, not something that's too big or too small for staff to accomplish in their role in your program, but something that can be done in a realistic way with the change that they want to make happen. It's not too much for them to accomplish, and it's timely. Ideally, you want a goal to something that can be accomplished in the next 2 to 4 weeks. The idea is that by focusing on small things that can be changed now, eventually they're going to see bigger changes in their practice, but they need to start with what they can change now. So that's what makes it a SMART goal. Now I'm going to share with you how you might go through this process of working with staff to take an idea they have into a SMART goal. So here is a staff member who's decided that he wants to help youth be better engineers. That's his goal. The first way he phrases that goal is, I will do more engineering challenges. He's going to do more challenges so that youth get better at being engineers. But as you look at that goal together, you realize it's really not specific, measurable, and so on. So you can help him think through this process. This is a good goal, but it's not a SMART goal yet. So what are the things that we can do to make it more specific and more measurable? So the second round, he's going to do an engineering challenge each week for the next month. Now we've got something quite specific. It's measurable. It's timely. We know it's going to be finished within 4 weeks. But could it be more achievable, more realistic about what actually is going to change because he's doing an engineering challenge each week? So then we get around to, I will do an engineering challenge each week for the next month, and we'll reflect with you about problem solving and working as part of a team each week. So by focusing on his reflection with you about these ideas of problem solving and working as a team, he's going to really focus their development in that area because that's what they're going to be asked to reflect on. That's what they're going to think about. And now you've got something that's a pretty good SMART goal. You know exactly what he's trying to accomplish, how he's going to go about achieving it through the reflecting and processing part. It's timely, it's realistic, it's measurable, all the pieces that we want for a SMART goal. And it's just a few minutes of conversation talking through each of these criteria to come up with a goal that really can impact the youth in your program. Now I'm going to give you a chance to do this. You've got a staff member who decides that she wants to help youth focus on developing perseverance. It's one of the things that came out in your chalk talk as you were working with staff. So the first goal, she says, is I'm going to spend more time on engineering challenges to help youth develop perseverance. I'm going to pause for a moment, and I want you to think about talking through with her each of these different goals, or each of these different criteria to make it specific, measurable, achievable, realistic, and then share some ideas in the chat box about what that's going to look like. It looks like the comments are a little mixed up here, but we talked about setting a time frame to do the challenge over a specific time so that you know what that is. I would have the staff member think about what techniques they would use and help them decide on one that they want to practice over that time so that they know what success is going to look like. Not try to just in general get better, but what specific thing are you going to practice? That makes it more achievable and realistic if you focus on just one strategy you want to try to implement. I would ask them to really think about how much time is more time, because in the example, one of the things that we talked about was that by having it for 2 days, they had 2 days worth of testing, and that might be a specific change she wants to make, but it's not clear from how the goal is worded now if that's exactly what she's talking about. So the idea here is that you would work with your staff to come up with a SMART goal that's specific, measurable, achievable, realistic, and timely. And then you're going to follow up with them, not right away, because you need to give them a little bit of time to implement their goal, but don't wait 4 weeks down the road. After a couple weeks, you're going to come back as a coach and see how they're doing on this goal. Are they getting frustrated? Are they feeling success on it? If they feel really successful now, is there something they want to change to up the bar a little bit? There's a lot of flexibility in how you actually work toward your SMART goal. The idea is to give them a chance to try this, to practice using the skills they're learning with youth so they become part of their everyday strategy of working with youth in your program. And then you'll see some real positive differences through that process. And before we get to the bottom line, let me go back to that model. So we had a meeting, we watched the video, we had the chalk talk discussion. Chalk talk is just a particular way of structuring that discussion. You can do it in other ways as well. But if you want to see how to do that, that's discussing testing in the design process, and you can download it from the webinar today. Then staff have an opportunity to practice, to do an egg drop challenge or another engineering challenge with youth and come back into some one-on-one coaching where you're getting feedback from them about how that challenge went, helping them develop a SMART goal about something specific they want to do over the next 2 to 4 weeks to make changes in their practice and help them develop their skills around facilitating engineering. Then you give them some more time to practice. You're going to follow up with them, see how they're doing. And then there's a web lesson that you can use at the end of this to help them follow up and kind of consolidate all of this learning. And you can find that on the Click to Science website as well. So that's how this process, this model looks like in practice with your staff. The bottom line, engineering practices are about much more than learning to be an engineer. It's about working as part of a team, perseverance, and problem solving. And these are the benefits that really are relevant to our work as an after-school program, as we want to emphasize life skills and helping youth develop their full potential through high-quality STEM activities. That's really what we're about here. Finally, I want to Encourage you to connect with us. We're celebrating American Education Week next week, and we're also going to have a booth at the National Association of 4-H Extension Agents, so I invite you to join us. Our next webinar will be on December 13th, so I hope you can join us then. And take a moment to fill out our survey at the top of the web links pod and give us your feedback about how this went. Thanks again for joining us today.